Now we have the next session from Mr. Harish Ganesan, CTO and co-founder 8kMiles. And he's going to talk about how enterprises are leveraging mobile cloud computing. Harish Ganesan is a CTO and co-founder of 8kMiles and responsible for the overall technology directions of 8kMiles products and services. He holds a management degree from Indian Institute of Management, Bangalore, and Master of Computer Applications from Bharati Dasan University, Trichy. Please come in, sir.
Okay, good afternoon. Is my voice audible? Okay. Okay. There is something in the middle. It's kind of gone, I think. Okay. So, good afternoon, everyone, and thanks for attending this session. This session would be more about how enterprises are leveraging mobile cloud computing in the context. So, I know it's a session before the tea, so I'll keep it faster as much as possible. So, what we are going to deal in this session is like some concepts about mobile cloud computing, the problem scenario. It's a case-based presentation, so we are going to take a case, and in that case, like what we did, I'm just going to explain involving the cloud computing. So the problem scenario, the solution approach we took towards that case, the before and after the case, and about 8kMiles and QA. We'll keep it quite simple. So what is mobile cloud computing? I just want to set the context here because there are various definitions about this. On here, we are going to see about how enterprises are leveraging mobile plus cloud computing together and using the solutions in combination. So let's take certain stats on what is the state of the current apps. So if you see, there are like more than 570k iTunes App Store and more than 300k Android apps that are getting developed. There are nearly like 50 plus apps every iPhone owner has, and 35 plus Android apps are in the Android mobiles, and over 300,000 mobile apps have been developed the last 3 years alone. So this is the state of the apps that are getting developed. So what is the smartphone usage in India? So you can see very much like 81 hours is being spent per month by the Indian male and female, and certain trends of things like online apps 29% and 16% by the male. So this is the most important one on the mobile cloud stats. You can see like the market for mobile cloud based mobile apps is expected to grow 88% from 2009 to 2014, and more than 240 million business customers will be accessing mobile cloud computing through their mobile devices by 2015. So, and what kind of services these developers are expecting to use in the cloud through the mobile? So majority of them would be in location services and certain on notifications and check-ins and all those things. So where does all these pointers lead to? It leads to one thing called as emergence of mobile cloud and how it's going to shape the entire world in the coming days. So now just we'll get into the case. This case is a mobile app, a cloud case that we did for one of the airline company. Their app was trending in Android and iPhone app stores. I think around millions of downloads when they launched it. It had a JSON based communication between the mobile and the cloud. The mobile app is not an isolated app in this case, which means this particular mobile app on the server side was integrated to a lot of apps. It's an enterprise system, so we cannot imagine it to be like isolated and running on the cloud. So it's been integrated with all the existing apps in the data centers as well. And the data should be fresh and always accessible, because this app, like if you see like people would book a flight or people would book a flight to online as well as they'll take the mobile and they want the the numbers to be available on the mobile. So the data is like kind of should be fresh and should be active between multiple devices. The mobile app will drive huge traffic during their sales promos, because like people use this mobile app for doing certain actions during the sales promotions. It had a constantly growing user base. So every day or every month, the number of people downloading these apps from the app stores are increasing. It had heavy spikes and valleys. In the sense, like on the server side, it had heavy spikes and valleys, because like it's not that people use this mobile app only on a particular time. Like they use it more on the promo period. Certain times they do use it more on the lunch or the dinner times. So there is a heavy spike and valley that this app was creating on the server side infrastructure. And it also required heavy processing at the back end, because it's just not a simple mobile app. It had a lot of dependency on the server side, so a lot of heavy processing was required at the back end. And storage, processing and extension help was needed from the back end. So the app just did not use the server side for processing, it used it for storing information, it used it for processing, and as well as extending it with other enterprise applications as well. So the problem scenario and the challenges. So a big sales promotion every quarter by the enterprise, and during this sales promotion, like they booked nearly 1 million of tickets just in a span of one day, and massive visitor concurrency through their mobile channels. So their mobile server backend should be able to handle that load, and multiple devices support is needed. So you can see that like they had iPads and tablets and phones and all those things. So the multiple devices needs to be attached to the cloud, as well as the data should be able to be moved between multiple devices, or it should be able to be accessible from multiple devices. So the data should be necessarily very fresh. And provisioning the mobile backend infrastructure takes a lot of time. So whenever during these promotions, the company had to spend, the enterprise had to spend a lot of time provisioning their backend infrastructure for their mobile app every promo, and it took a tremendous amount of time for them, because they were not able to plan their capacity, they were not able to plan many things ahead. You have millions of downloads, you don't know suddenly million people will be using the app, or whether it is going to be like few thousands using the app. The load volatility was very fluctuating. So you can see like during the promotions, they had very peak utilizations of their capacity, and during the non-promotion days, their capacity was massively underutilized. So because of this utilization patterns, there was a heavy cost leakage on the server side that was happening on the cloud computing side for this particular mobile app. So they wanted some kind of solution to address all these things. So they wanted typically a need for auto scaling of the backend resources, because they very well know like with such fixed capacity designs, they cannot achieve, they cannot solve this problem. They cannot solve the problem of cost leakage and all. So they needed auto scaling of the backend resources. And since it's an enterprise, they necessarily have all the security requirements. They have the encryption, the identity access, the authentication, authorization, compliance, DMZs, firewalls, VPNs, everything for any infrastructure cloud backend that you build. So now that we got into the problem scenario, like we very well know there are problems on the security, there are problems on the scaling, the elasticity and everything. The solution approach, what we took, I'll just explain. So the first step was to choosing the right provider for the mobile cloud backend. We went through a lot of providers, and finally we came through 2 providers, either it's Amazon Web Services or Windows Azure, for solving this need. and we choose AWS as the mobile cloud backend for this customer. There are 3 icons here: smartphone, pad, tab, and PC. I think probably I did it in a different version of Windows and it's not coming. Okay. So we choose AWS because of its presence in the global infrastructure, its stability, its worldwide footprint, and tomorrow if we need to geo-distribute this app, the server-side background, the server-side infrastructure of this particular mobile cloud app, we could very well do it. So we choose AWS for that, and we can as well elastically increase your EC2, DB, and NoSQLs and all those things in the back for this particular app. So AWS was the choice for us, and AWS also provided mobile SDKs. There was Android and there was iOS SDK. There was a wide variety of protocols supported on AWS. You had JSON, BSON, SOAP, REST, HTTPS, TCP, RTMP. A lot of protocol support was there, and it also had a wide variety of server-side language support. So you had Java, Python, PHP, and Ruby, .NET. So you have the flexibility in your hand when you are designing your mobile cloud backend. And ultimately, like, you can pay as you go. You can use on-demand or reserved instances, and the pay-as-you-go model gives the flexibility in terms of cost. Whatever infrastructure that's being used by the mobile cloud backend, that's what the enterprise ends up paying. So the second concern that we kind of addressed in terms of the architecture was securing this mobile cloud. So to secure this, as I told, like, they had requirements on compliance, VPN, DMZ, and all those things. So we cannot just about architect and put this on the public part of the Amazon cloud. So we choose with the virtual private cloud of Amazon. Virtual private cloud is an isolated subnet inside Amazon's public cloud itself, and we created a virtual private network to their existing data center. So from the Amazon cloud, the virtual private cloud of Amazon, there was a VPN connection established to the corporate data center of this enterprise. This enterprise had 3 other data centers in a different country as such. So from Amazon cloud, we established the VPN connection to all the 3 data centers as well. And the next step was like establish a private public subnet in their VPC. So typically, if you see in enterprise, whenever we design the infrastructure, we always keep it in the DMZ with public, private, and all those things. So we had to do that following their guidelines, and we had to do that on Amazon. Then identity access management policies. Identity access management policies are kind of like user-based policies, who can access and all those things. So those things were configured. Security groups with tiered restrictions. So we can clearly define, like, from this layer, when contact is made to another layer from your web app layer, if the contact is going to be made to your database layer, what kind of ports needs to be allowed, what IP ranges are to be allowed, and all those things, what protocols are allowed in each and every layer. Then hardening of the OS typically, so that like no hacker can get into through that layer, and load balancing with SSL. Typically SSL was the safest protocol on that, and data encryption on the DB and the storage layer. So data encryption would be like either on the application, you do the encryption and put it on the storage layer, you can do it on the S3 part. So these are all certain things that were done in terms of the security part to handle the mobile cloud backend for this customer. Then managing the integrations. So what we need to do is next is, as I told you, the customer, this particular mobile app is not an isolated app, and it talks to multiple other applications in their existing data centers. So this mobile app needs integration with their CRM, needs integration with their email for sending alerts and notifications, and like you book your ticket through your mobile, you might need your notification on your email. So since it's an enterprise, they already had their email systems running in their corporate data center. So even though your mobile cloud backend is running on cloud, it needs to be seamlessly integrated to their corporate data center as well. And other couple of apps they had which needs to be integrated from the mobile cloud to this. So this was one. So it was done over VPN based connectivity to the existing enterprise data center. So from the mobile cloud we established a VPN, and through the VPN we talk to the CRM, email and the other apps in this scenario. The next was, this particular mobile backend also talks to third-party service gateways. So when it talks to third-party service gateways, these specific gateways require the IP ranges from the cloud. So whenever you talk to a third-party service gateway an enterprise level, they will say, in my firewall I need to whitelist certain particular IP addresses. So I need to know from which IP addresses these web service request calls are to be made. So if that is the case, you need to know the IP address from which your app server is going to make contact and register with the third-party service gateway. In Amazon there is a concept called as elastic IPs. So we kind of use this elastic IP within the VPC so that we were able to give consecutive elastic IPs to the customer, because this was like one of the important cases. Many cloud providers currently cannot give this, and this is a big bottleneck when you are designing enterprise applications, because if the third party gateway says I want a continuous list of IP address to be whitelisted in my firewall, and if your cloud provider cannot give that, your entire implementation would be in breakneck. So this was one of the important decisions based on which we took Amazon itself as a cloud provider. So we got that from the elastic IP and with the VPN, and we provided and listed that in the third party service gateway. And the other integrations were on typically on HTTPS, TCP, JSON and BSON protocols with the mobile and other services. So the step 3 was managing the integrations to all the third party service gateways, to the existing corporate data centers, the applications running in the corporate data centers, as well as to the mobiles and other applications that are running in the cloud. The fourth was scaling the mobile cloud. So this was one of the important reasons why this customer is moving to a cloud itself, because traditionally you have a mobile app, you distribute the mobile app. It's not new to an enterprise, right? Enterprises distribute the mobile app and they have their background servers running, the backend servers running on their data centers. So it's not new to them. But why they move to cloud? This specific objective is very important, because their existing data center, their existing backend that they are running for serving their mobile applications was not able to scale. So during the promos, like suddenly there are fluctuations of thousands of people accessing or the information through the mobile device, and their mobile backend was not able to handle that load. So they wanted a highly scalable solution for their mobile backend. So this was the one of the main criteria for which a mobile cloud solution, a cloud solution itself was fit for the backend. So what we did is, like, we used inherently scalable AWS building blocks like Route 53, ELB, S3 and all those things. Route 53 is the DNS, ELB is the load balancing, and S3 is a storage, file storage, object storage kind of layer. So these were used in the architecture. The second step, we used Amazon auto scaling for their web and application layer. So you have the mobile, you have the smartphones. The smartphones contact through the firewall and all those things. Once the security, everything is done, it reaches your web app. So your web app is where your processing code lies. So your web app now is designed with Amazon auto scaling, so that depending upon the number of requests, your web apps will scale out automatically to multiple EC2 instances. It's not a scale up, but it is a scale out. So now you have 10,000 concurrent requests coming from the various downloaded mobile apps, and now it suddenly increases to 20,000 concurrent requests per second. In Amazon, you can dynamically provision your background servers, your web app servers in minutes to handle those load, and those servers could be attached seamlessly to your Elastic load balancer so that your load balancer starts working in tandem with them. Okay, so this was done. And the third was scale out and down. Scale out and down was done typically, like when the load is more, your servers, your web app servers will be scaled out. When your load is kind of less, your web app servers will come down dynamically. Custom scaling scripts were used for some of the layers because they didn't just have the web app. It's not quite simple. Like whenever you design any mobile app or anything, your server-side background for an mobile app, it's not going to be just your web app servers. You may have certain other layers as well. So for certain layers, we use the custom scaling scripts. We didn't use Amazon auto scaling. In Amazon, you can do scaling either using Amazon auto scaling, or you can even write your custom scripts. The APIs are provided. You can tie it up and make the scaling on your own. And overall, they had improved experience for the mobile app users during the peak load, because they were always kind of finding it difficult. Now my user base is kind of growing, and when people are accessing through the mobile, the latency is more, it's kind of slow, and certain times the requests are not getting served. So all those problems kind of solved and improved after moving the application onto the cloud. So the next step is to build high availability for the mobile cloud. So if you see, there are millions of downloads. Now you have secured the application, you have scaled the application, and if you do not build high availability aspects in your backend, then it's of no use, because if your mobile backend is not highly available, then it's like having no mobile backend itself. So if my entire data center or something is going to fail and all my mobile apps are not going to be served, that's as equal as like not even designing your backend. So this is another critical part on designing your mobile cloud backend, and we designed certain specific aspects on high availability using Amazon Cloud for this. So we built high availability on the web app level. So if any of your web app server goes down, your request would be routed to other web app servers dynamically. So for a mobile app user, you won't even know that the web app server, something on the server side background has gone down. So your requests are seamlessly transferred to other web app servers. Second was high availability was built on the DB layer. We used the master slave, and we used shards and all those things for this. So that like when your master fails, your requests are sent to the slave, and the slave gets elevated to the master and all those things. Then high availability was built at availability zone level. Availability zone is Amazon's concept. Availability zone, like every region in Amazon has got something called as availability zones. So availability zone is like, you can visualize it like a distinct data center which has got separate power, cooling, security, network, and connected by low latency network. So when you design applications on Amazon, so you should design it with 2 availability zones, leveraging at least 2 or more availability zones. So this particular mobile backend that we architected was leveraging multiple availability zones. So your web app servers were running in multiple availability zones. Your database servers were running in multiple availability zones. So if your entire availability zone, a data center itself, fails, still your requests are served from the applications, the database, the tiers running on another availability zone. So this was high availability built on AZ level. So this is also one of the prime reasons we took Amazon, because like such things are easy to be built on Amazon. And we also used like inherent fault tolerant blocks like ELB, Route 53 and S3. Like these are all inherently fault tolerant. So one of your load balancers in your elastic load balancer tier goes down, another would be automatically and seamlessly replaced for you. So ideally, the success of the mobile cloud is the robustness of the mobile backend. So this is very obvious. So this is what we took and we built on the HA layer. The sixth step was designing the IT ops. So once you have built all the layers, like you have built your security, you have built your scaling, high availability, everything. Now there are other aspects to it, like how do I do monitoring, how do I do my backups, how do I do my analysis of the logs that are created and all those things. So we used certain methodologies for this. So the logs that were generated and all these things were collected and moved to a Hadoop cluster that we had built inside. In the Hadoop cluster, like we did a log analysis for them. The monitoring was done using CloudWatch and Nagios. CloudWatch is a Amazon monitoring tool, and Nagios is an open source tool, like many of you would already know. And then the automated AMI snapshots and periodic backups to S3 were taken. Like your web app servers, we took like automated AMI snapshots. So whenever versions or whenever certain things are built, whenever golden AMIs are built, your automatic snapshots would be taken and moved to S3, as well as like periodic backups from your database and all those things will be taken and moved to S3, as well as the log files that are getting generated on your web app servers are moved to S3 periodically. We used Puppet for deployment because like during the peak loads they have like probably around 60 plus EC2 instances running, and certain times you need to push in case it's an enterprise, like things are running and they want to push some patches or something. So we need a mechanism where we can push the updates, push the patches into the web app servers. So we used Puppet for deployment. All the sources and the executables were deployed using Puppet. And the entire infrastructure was automated. Like in case your load increases, your infrastructure expands and collapses once the load goes down. In case like any of the boxes goes down, it can be automatically detected and replaced. It's not done through manual mechanism. Everything was automated through scripts and through programs and APIs. And it is like easy for maintenance. Like once your infrastructure on the back grows, it has to be easily maintainable. And that's what one of the main objectives of cloud is. And we did that as well. So typically HDFS, S3 and CloudWatch were used. And what was the before and after scenario? Because like after going through all these things, we need to clearly evaluate and see what was before and what was after. So provisioning and deployment efforts were taking days before moving to cloud, and after like automated cloud provisioning, like 60 plus VMs we were able to create in just 25 minutes. Only manual scale up was possible in their traditional system, traditional infrastructure, that too in days. But after moving their mobile backend to cloud, we were able to do using Amazon auto scaling. Their capacities were able to increase and decrease in just 3 minutes time frame. Ensuring high availability was done manually in hours before, and then like post moving their application onto cloud, automated self-healing was done in minutes. Upfront capex before, because whenever sales promotion comes, like they need to plan all their capacities, they need to provision all their capacities. Certain times they will have to go and take lease depending upon the promo size and all those things. And pay by usage in thousands. So this is typically the Amazon way, because like you use 60 servers for just a few hours, you just pay for those. And they used to spend a lot before, and now they are spending in thousands. I can't tell the number, but I can just tell like in a day if they book million tickets, so you can imagine that in terms of the revenue that they make, and in terms of if they spend the entire infrastructure in thousands, that's nothing compared to them. Business was lost during the peak load before, And now like more business conversions were happening because of auto scaling, because like customers had very good experience and they started downloading more apps. Leakage was in cost, and efforts and costs were there. And after moving their entire infrastructure into Amazon, during the sales promo alone, we were able to see they were getting 60% of savings on their infrastructure cost. So this was the post comparison. So this case is kind of relevant not just to this particular airline or whatever case, mobile app. You can deploy it for your mobile apps that you are developing on your e-commerce or travel, media and education, like whatever mobile apps. You can use cloud computing as the backend. And just a short note about us, like we have 4+ years of experience on cloud computing. We help enterprises leverage cloud, mobile and big data, and we do architecture, consulting and development. And I'm ready for the QA. I hope it was like useful. I gave some information on that, and now I'm okay for the QA. Yeah. Okay, you shouldn't take like just not that kind of criteria. I told you one thing about this IP addresses, the listing of the IP addresses on customer gateways. We need to see when we are designing the backend infrastructure, which cloud provider is the right. Azure also offers like a lot of things, okay, very similar. So if you take like the IP address part, at that time when we are designing this, Azure doesn't add that. So that was one of the primary criteria for which like we had to take it out. Yes, you can build an Android app, could be your client, and very well it can use the cloud services. Azure, like just take like I think 6 months back they even introduced gaming APIs on Azure. So if you are building some gaming applications, you can use Android and contact it through. On the server, you can use Azure as your server backend.
Harish, here.
Yes.
So the current customer, how are they currently managing and visualizing this entire architecture? Do they log into the AWS console and look at it, or you have a customized dashboard for them to?
No, we don't have a customized dashboard. They use AWS console and they use certain other management.
Okay, and let's say for a particular period of time when they can anticipate a load, obviously they do pre-provisioned set of instances.
We do that as well.
Okay.
So just before the promotions, we stack up their VMs to 60+ VMs 25 minutes before the promotions. And during the promotion, if they have any fluctuations of load, Amazon auto scaling will kick in and will start just patching the need. And post promotion, probably after 2 hours, we'll start decrementing the EC2 instances. Okay. So there are ways in which you can pre-configure those.
So this happens while a backend activity, or it's again something?
Everything is automated.
Automated. Okay. Thank you.
In the security slide, you mentioned that there is something called hardened OS. What do you mean by hardened OS in AWS?
Typically, like you have Linux in Amazon. You have Linux is lot of. It's called as Amazon Machine Images, and they are built by a lot of people and put on the Amazon Marketplace. So when you choose a OS, it could be readily available for you to use. But on an enterprise scale, since they have security requirements, there are a couple of things we need to do. A simple thing, a lot of unwanted ports, and like Red Hat comes with the IP tables when you have a Red Hat launched. But these IP tables will have certain restrictions done when you are communicating outside. There might be a lot of unwanted services that are running. You can harden all those things. We do certain other things as well, but I can provide you that detail other than this.
Okay. And another question is regarding the auto scaling. In one of the slide you mentioned that you do auto scaling feature of you use the auto scaling feature of Amazon, and also you have a script to do the scale up or scale down. So what is the need for doing a script if Amazon provides the auto scaling by default?
It's a very good question actually. See, Amazon auto scaling, if you try to deeply understand auto scaling, Amazon auto scaling, you can use it only for certain layers, the web app layers. Okay. Let's imagine you want to scale your instances. You have a queue, and there are messages flowing into the queue, and you want to scale your instances depending upon the messages on the queue. You could very well use a custom scaling script for that. That's one. Another one was like currently Amazon's auto scaling can work only with like the CPU or your network and all those things. We even faced a scenario where we need to scale based on the number of sessions that are logged in. So what we had to do is we had to write a Tomcat valve, and this valve will send the information about the number of sessions, the connections that the particular Tomcat is handling through the CloudWatch, and a centralized program will read all those things. Okay, this box has got like now 10,000 sessions already, so this box cannot handle more, so I need to have another box created based on that. So such things you can do with custom scaling, and it is possible if you deeply understand the APIs of Amazon, you can very well do it.
So you're detecting
you have both auto scaling and your custom script. Does it not over provision in some cases?
We won't use both for the same.
So you're detecting the load at the application here.
Oh, okay.
So you're detecting the load at the application level.
Load, it's just not the application level, because if there are multiple layers, if you see, you need to see what kind of load each and every layer is going through. So your web app goes through the request load, and that can be done through auto scaling. You might have certain background programs which needs to be stacked up and scaled. So for that you can write custom scaling, and that could be measured with the number of requests waiting on the queue. Then you have the database. Surely nobody will do auto scaling. You will have to do structured, manual, automated, intelligent programs which can scale. So what we will do is like certain times, not for this customer, in other scenarios, it's a read intensive site, we'll create multiple read replicas dynamically in Amazon. Okay, if it's a read intensive site, in your database you have a master and you have a slave, you can create multiple read replicas, and these read replicas can be accessed by your web app layer. But your master and slave, you should very well plan the capacities, and possible you should shard it and keep it before, because there is a maximum number of connections, parallel connections any database capacity can handle. It cannot go more than that, depending upon the hardware.
Yeah. In continuation to that, did you use Amazon RDS, or what was the database used?
It's MySQL, Amazon RDS.
Was it Amazon RDS or your instance of MySQL?
It is Amazon RDS for me.
Amazon RDS. So what is the data volume currently that your site is?
Data volume is kind of not very high and all here.
Okay.
The only thing is the parallelism we have to see, because if you take Amazon RDS, let me imagine I take m1.large in Amazon RDS. You can handle, it comes with 7 GB of RAM, it comes with like 2 cores. But the number of max connections that it can technically handle, or you can push it through, will hit somewhere around 600, 700, right? You can push it through 2000, but there is a limitation to that. So if you have like a lot of people who are going to hit from your web app layer, if your web app layer is kind of auto scaled and they are going to make a lot of connections into your database, you can't make it to one database. So ideally you should have shards of multiple database and done.
So was that the way your current?
Absolutely.
Okay.
Any mission critical, any highly massively concurrent application, we shard. So Probably I will be presenting another session on 4:15. I don't know, it's not confirmed.
Okay.
So if I'm presenting, I'm dealing about something called as art of infrastructure elasticity, where I'm going to talk about architecting. We have done one architecture for application handling 500 million requests. So it's a different way of handling. It doesn't use traditional methodologies. It uses like NoSQLs and all those things. So let me see if it's confirmed. I can reveal on that.
Okay, thank you.
Yeah, one question. Let us assume if we develop the app in Android framework, so how quickly we can leverage that development efforts in iOS framework as well as Windows SDK frameworks?
It depends upon how good the developer is.
So
See, one thing is, I'll take the question in terms of cloud computing, mobile cloud computing concept. So you have developed for Android first. So you have exposed certain web services on your mobile cloud backend. So your web services are being used by your Android app. Now you go to and develop an iPhone app. Your mobile backend remains the same. So you replicate it to a Windows, it uses the same web services. So you have to see only the effort for developing the client side, but your server side is intact. It can serve various apps as well. So that's the benefit it gives. And this is not applicable to all the mobile apps that you develop, because there are a lot of mobile apps which are there in the market which doesn't even need a backend, and which doesn't even need a cloud backend, right? So if you take Instagram's case, Instagram uses Amazon heavily for their backend for handling.
Yep.
Okay. Thank you.
Thank you so much, sir, for your deep insights into mobile cloud. Now, on behalf of UBM, I would like to take this small opportunity to present Harish with a small moment.